Okay, we are now beginning the shear of Magel Hayarech. That is on Perik Yud Zayin Halacha Yud. So, what is this Magel Hayarech all about? The answer is, let me get the right screen. Oh, okay. So, we have explained earlier what is the goal here. What is the goal? The goal of this, this is introduction to understand Halacha Yud, Yud Aleph. That's it. It basically goes different times. So what are we doing? Before understanding why we're doing it, let's first know what we're doing. What we are doing here is like this. We have here a oirach sheni and a reichav sheni. That is a longitude and a latitude of the moon. Let's take an example. Let's say the moon is 35, means it's the beginning of Shire, the latitude is 5. We can have anything. And we know we can only have 5 or negative, up to 5 latitude or negative 5. That's the maximum latitude we can have is 5 degrees. We can have 50, negative 5. We can have 13, 3. We can have any longitude and any latitude ranging from negative 5 to 5. This is number one. This is how the cheshbonis are made that we have right now in our hands. We know the moon's longitude and latitude. We also know, we showed previous video, that there's a way of converting ecliptic coordinates to right ascension coordinates. I'll not show it again. You have to look at previous videos. I showed a grid system that you can, there's mathematics how you can do it, there's a grid system. So every coordinate in ecliptic coordinates, let's say we say the moon is 35, the right ascension of it is, let's say, 27, 7. So declination right ascension. We can switch from one system to the next. You must understand that. You can look at previous videos to understand that. Next, we also understand that the ecliptic itself means where the latitude is 0, each point has also a right ascension and declination. Why not? Just like we can convert any point of the ecliptic into right ascension declination, for sure we can convert the ecliptic itself, that means where the latitude is 0, we can also find the right ascension and declination. And actually, I'll just give you one that we know, that 90 degrees of the ecliptic is also 90 degrees right ascension and 23.5 declination. That's, we know. And then the other ones are just there. There's a formula to find out each point in the ecliptic, what's its right ascension and declination. Now comes the step number 3 that the Rambam is doing here. We would like to find the right ascension of the ecliptic coordinates that has the same right ascension on the ecliptic. So, assume that we had found that the right ascension of 35, the right ascension is 26. The right ascension of that is 26. I'm not gonna, declination does not interest me now. Assume that's its right ascension. Now I'm wondering which point on the ecliptic has a right ascension of 26. maybe 28. So we will right now get this point of the ecliptic 28. That will be the Oirich Hashlishi. And Magal Ereich just means we're adding 2. We're adding 2 degrees from 26 to 28. That's the number we must add or subtract to get the same right ascension that the ecliptic coordinates of the moon has. We want to find that same right ascension on the ecliptic itself. Why? Here's the big question. Why? Everybody's curious to know, what are we doing here? It sounds like so complicated and so confusing. What is the tachlis of this? The tachlis is, we explained it in the previous video and I'll say it over again. The tachlis is, we will show soon, the next video, a certain chart that tells us each point of the ecliptic, how long it takes to set. Meaning to say, you know a certain point on the ecliptic is on the horizon in Eretz Yisrael. You would like to know how long will it take for point B to set. You'll know how many, there's a chart that the Rambam had and we have. It tells us, so imagine you have that chart in front of you, easily accessible. So we have here a thing that's not on the ecliptic with latitude 0, it's the ecliptic with latitude 5. How would we know how long it takes for that point to set? So we came up with a clever idea. Let's figure out which point on the ecliptic with latitude 0 has the similar right ascension to that point of the latitude and longitude of the moon. And we can make a certain hekesh. We can say, just as this point of the ecliptic will set in 55 minutes, on 45 minutes, the same, that point that also has the same right ascension will also take the same amount of time to set. Now, it's not 100% true, because you're right that there is a certain truth to it, that points with the same right ascension set have a certain reason to set the same time. Yeah, well, because it's the same right ascension, so they all, we showed in the previous picture, they all are the same lines of right ascension, but there is a certain fact that's called Roichav HaMadina, that if you live in New York, so we have to take in consideration that if there's a certain declination, we have 2 stars. They both have the same right ascension. Okay, that's quite beautiful. But if one star has a higher declination, we have to take in consideration that also. But at least we took in consideration the one part of the formula. So there's 2 parts that somehow, if you want to figure out, like, you want to speak very vague and roughly, you say 2 things that cause something to set in a certain time: the right ascension and the declination. So first, let's take care of the right ascension. Let's take this. Let's adjust this point that since they have the same right ascension, they will set the same amount of time. And then we will look in the chart, the point of the ecliptic with that right ascension, how long it takes to set. We can say that the same time it will take for the longitude and latitude of the moon, what you have right now, will also take the same amount of time to set. And then we will adjust again. That's going to be the last part of the Rambam, Roichav HaMadina, Manas Roichav HaMadina, to adjust for the fact that we're dealing here with a different latitude, with a different declination. We have, since it's a latitude that on the, we can somehow approximate. You can say, since it has approximately that latitude, that's approximately the declination. So declination changes with so many degrees. We have to add some time because it's a higher declination or a low declination, whatever it is. We can adjust that later. But right now, we're only adjusting the part of the right ascension. So this is basically what the Rambam is doing here, and we still have We still have a few minutes left, so let me finish this chart at least. So you take a look at this chart here, you would see this is showing from 0 till 90. From 0 to 90, we're working here. Oh. Okay, it's blocking. These things here are blocking. I don't know how to get rid of it. No, 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 no. Okay, let's get just back to this. 0 to 90. This is from negative 90. Okay, I think this will also do the job. So this is from negative 90 to 0. We see from the chart that by Tele, it's a little bit more than 2 degrees. That's a Magel HaYereach. The Ram says Shnei Chamishav. This chart is made when the moon is 5 degrees positive latitude. That means Roicha Vayrech is 5 degrees. And we see that the highest Magal HaYereach is by Teleh. Meaning to say, when the longitude of the moon is 0 and the latitude is 5, then we must subtract more than 2 degrees. The Rambam starts off mit Tilchiras Mazel Tle ad Esher Miles. At that time, we have the highest, we have 2/5. So 5 degrees, so this chart is for 5 degrees, so 2/5 is over 2 degrees that we must subtract. And we would say that we will use the point of the ecliptic that's 358. Because we have to subtract 2 points, 2 degrees. And as you can see, that this direction is negative 90, so that's, it gets low. By negative 90, then there's nothing, there's no Magle Erech. So this is a chart for negative 90 to 90. This is a chart from 0 to 90. You see here it goes, it matches these two charts. And again, by 90, it's not perfectly symmetrical. It's almost, but it's not. For example, take a look here. By 6D, you see 1 and something here. But here by negative 6D, it's a little bit less. It's not exactly symmetrical. This is 0 to negative 90, and here we have from 0 to negative 2. So we see again by negative 90, this is made for 5 degrees negative latitude. Okay, this is again 5 degrees negative latitude, and it's from 0 to 90. So there's 4 charts. There's from negative 90 to 90, from negative 90 to 0, from 0 to 90, and then both by positive and negative. We'll continue.